In this video, I'm going to talk about Euclid's proposition 1-6. Now, Euclid, first of all, drew a triangle. Now, you could draw an isosceles triangle or an equilateral triangle, doesn't matter, either one, okay? But he says that we have a triangle A, B, and C. And then he says, we're going to start with this triangle. We're going to say that angle ABC equals angle ACB. And he says, because of this, we are also going to say that that line AB is equal in length to line AC. And that's the part that's in question. He says, let's just suppose that AB here was not equal in length to AC here. And he says, well, we're going to use proposition 1-3 to make line DB. And DB would then be equal to AC. Okay, so DB, he's saying, hypothetically speaking, DB is equal to AC. Now, obviously, you can see that that's not true, but that's what he's saying here. Alright, now I'm going to flip this paper over here and prove out the rest of the theorem. Okay, now, he wants line DC to be joined. Now, I'll flip this back over and I can show you that we joined line DC. Okay, so now we have another triangle here that's called DBC. Alright, so now we're going to deal with both of those triangles. Now, he's saying that since DB is equal to AC, so you have DB equally to AC, he said, and because BC is the common, which is here and here, okay, because they both had BC as the common, and what that means is that this length BC is going to be equal to this length BC because they were equal in the first place. Alright, then he says that we actually have an angle here, which is ACB, which is equal to angle DBC. Now, how do we derive this? Well, angle ABC was equal to angle ACB originally, and so therefore, just because we cut off letter D didn't change the angle any at all, so DBC is still equal to angle ACB. Now, that would also make line DC equal to line AB. And that would then make the whole triangle DBC equal to triangle ABC. Well, obviously that's absurd because we already established that DB did not equal in length to AB. So that's absurd, and so therefore the whole theorem is absurd. So therefore, going back to this, we can now safely say that AB equals AC, which you now have an isosceles triangle. Alright, hopefully I didn't confuse you too much. Basically, what the theorem is saying is that once you cut this line off, you're actually saying that triangle DBC is equal in size to triangle ABC, and that's just absurd because you deliberately made it not so. So therefore, when you have two sides like this, AB and AC, they're going to be equal. Because otherwise you're going to have two triangles of unequal size suddenly being equal, and that's absurd. Alright, I'm going to cover more topics in a future video, so stay tuned.